All right, so we're going to talk about Angular, and we're going to talk about testing in Angular. Actually, one more question before we get started. Who here works in Angular? Who here has heard of Angular? Who here uses JavaScript? Okay, so I know some of you are lying because you had none of, like, there are people here who just didn't raise their hands. Who here owns a computer? Okay. Who here has legs? I'm looking at you. All right. So we're going to talk specifically about testing, and we're going to talk about testing on Angular. The goals of today's talk is to answer these questions. What does it mean to test? Why should you write tests? What is a good testing technique? And how to test different components of our application. Unfortunately, we don't have enough time to get every part of your application, so we're going to talk about the different types of tests and look at a few ways to write tests for different components. Before we get too far into that, let's talk about. Let me just tell you who I am. My name is Ari. I wrote a book on Angular. Actually, I wrote several books on Angular. I'm in the process of writing another book, not on Angular. I teach here in San Francisco at a company called HackReactor, or a school called HackReactor, and various other schools here in San Francisco. And I have a background in distributed computing and big data processing and infrastructure, and I'm really into deep learning, which has nothing to do with Angular. These are the books I referred to. Cool. And I'm also kind of, as a way to wrap in teaching for not only the people that I can speak to in person, I'm also doing webinars and stuff online. If you're interested in, there's no way we're going to get through all the material that I have today, or I'm going to give a similar yet more in-depth talk online, and you can find out more details at ng-newsletter.com. Okay, so back to the talk today. I strongly believe that testing is a core component of development, and I actually kind of even though I made this diagram, I kind of argue with this diagram in the sense that I think those two things are one and the same. So what does it actually mean to test, and why do I hold that opinion? Testing itself is a way of looking at our code and making sure that it runs the way that we expect it to run. There are always going to be edge cases when you write code. There's always going to be the case where your code just does not run, unless, of course, you're writing assembly code, in which case your code is always going to execute exactly how you expect it to execute until there's a power surge. Specifically today, we're going to talk about front-end testing. And testing the front-end, testing our browsers, has traditionally been pretty difficult. One of the reasons it's been difficult is because there's a lot we have to do when we're writing front-end tests. We have to load a browser. We have to set up our JavaScript expectations. First, we have to have a library to actually set our expectations up. Then we have to execute those exceptions, capture the output, and then use the output to measure and compare against our expectations. And then we have to, in order to do this in kind of a meaningful way, other than just pointing and clicking and making sure that things kind of run when you press Apple R and refresh your browsers, we have to do this all in an automated way. We'll talk about how we as developers in 2014 have it a lot easier than we as developers in 2010 and before. We'll look at the different tools that we have available to us today to handle a lot of that browser automation and expectations. So there's two types of tests. There's arguably a couple other ways of testing front-end code, but the two typical types of tests are unit testing, which is testing code, and end-to-end testing. Unit testing is basically testing small components of our code and our functionality. So unit tests are particularly good for developer. They're developer facing tests. End-to-end testing, on the other hand, is we're automating clicking on a site. We're automating loading a site, submitting forms, seeing if elements are there, seeing if the browser is doing what we expect the browser to be doing. And lastly, before we actually jump into working on stuff today, I get the question a lot. I do a lot of training for, like I said, in schools like HackReactor, and I also do a lot of training in like the corporate setting. And a lot of questions we get are things like, well, do you believe in test-driven development? Do you guys know what test-driven development is? It's kind of like an old term. Yeah. It means writing your test before you write the functionality of your code. That's why it's driven by the tests. I don't actually believe in TDD. I believe in test-focused development. What I mean by that is, well, that's in the wrong spot. What I mean by that is writing testable code, writing code that you can come back later and write a test on. So you're, as opposed to writing the test and then you know that your functionality is done when you write the test. A lot of the reason why I believe that is because, especially in the front end, our API, our developer-facing API, is constantly changing, especially when we're prototyping. And if you're writing tests for an API that is likely to change, that is going to change, then you're wasting development cycles on writing something that you're going to throw away. So I believe specifically in test-focused development. So what is TFD? So this is, oh geez, that is tiny. Can you guys read that? Well, if you have edu.ngrok.com open on your screen, you can totally read it. You might have a function like this inside of your Angular app, where you have a load friends function, and you only want to load the friends, or you want to load the friends from your, either from your cache, or you want to load it from a service, like your API service, for instance. This looks like kind of a reasonable function to do that, right? But this is super hard to test. That is like, if you're writing a test for that, you are writing a whole bunch of edge case tests that you don't need to write. You're like, simply because your code looks like this, your tests are going to explode in terms of size. Whereas if you were to write that same functionality like this in different functions, and albeit that this function right here is just kind of a little bit too big for my taste, but if you write it like this, then you can stub out those specific tests when you're writing a test and test that specific functionality for that test. So I say TFD, not TDD. I also do believe that console log statements are okay, as long as you don't do a git commit with the console log. Okay, so when should we write tests? We should write tests when we're fixing a bug, isolating an issue, adding a new feature, when we bring a new developer on the project. Tests are really good because when that new developer joins, and at some point you may have been that new developer, you're like, well, what's broken? How do these things work? Especially in a large code base. Having a test there to demonstrate exactly what that API looks like is really good. So let's talk about the process of testing. The process of testing is, I believe, in four steps. We want to isolate the functionality that we want to test. We want to set an expectation for the functionality that we're writing. Set the given conditions for that functionality, and this is like an array, by the way, where you're like, oh, I have this condition, this condition, this condition, and this condition. And then the last part of it is compare the given conditions with the given output. So, for instance, we might want to isolate a functionality like this. We have a function, and this function does one thing. It says build full name based off of a first name and a last name. So in order to test this, we would have to set an expectation. By the way, I didn't include the introduction to Jasmine in this because we just don't have enough time. We're using Jasmine. If you're not unfamiliar with Jasmine, it's verbose. It's terse enough such that you should be able to understand it. If you don't understand it, that's cool too. Just join the webinar because I'll be covering Jasmine. Okay, so using Jasmine, we would set an expectation like this, where we use the keyword expect, and then we call the function. And we call the function based off of a set of given conditions. For instance, the given conditions that we're calling inside of this test is we're building the full name with a first name and a last name. And then we're going to compare the output of that with the expected output. All right, so for the rest of the talk, we're going to be using this code. It's available here. This will link you to this, and you can just click on download zip on that page. So it's j.mp/ng testing, all one word. know, so hard to click download. Okay, I'm going to move on. Okay, so the way that we'll run our specs, as you guys are downloading that, hopefully the internet is good enough for it. Not the internet is good. The internet's good enough, guys. Trust me. Our access to the internet is good. So we're going to be using a tool called Karma. The way that we install Karma is using the npm node package manager binary. We'll install that using npm install Karma. So in order to use Karma, we need to give Karma a configuration file. We'll give Karma a configuration file by using the Karma configuration generator. We can use the generator by using the command karma space init. Are you guys following along, or should? Yeah? Okay. This is recorded, so if you lose your place, it's cool too. Great. So karma init itself will bring up a screen that looks like this with a bunch of different questions that it will ask you. I particularly press enter for every single one of these questions, regardless of what I'm doing, because manually setting it up is way easier than not. So feel free to do that too if you're following along. It will give you a file that looks something like this. There are three things inside this file that you should pay attention to. One is the files array. The files array basically taking a step back, the way that front-end testing works, the way that Jasmine works is we'll load up a browser and inject a bunch of files into that browser, including your dependencies, your application, and your tests. And so this files array represents the files that Karma will inject into that running browser instance. So every time that you have a dependency, it needs to be listed in here. You can see we have Angular inside of here as a dependency. Anytime that you have new application code, you have to put that inside of this files array. By the way, this supports globs, as you can see here in our specs. So if you just have like an app directory and you just want to be like, I'm just going to include all my app directory, then you can do that. And then this also takes all the tests that we're writing. So the second parameter that you should pay attention to is the base path. This is just basically where to resolve your files from. This is particularly key when you're developing modular-based applications. And then the last one is AutoWatch. AutoWatch does exactly what it sounds like. It will watch all your files, and when any of them changes inside that files array, it will rerun all our tests. And that should say unit testing. All right. So unit testing, as I already said, it's really meant for the developer who sees the code. It's not meant for a user, an end user. Right. I put this in a weird spot. Lastly, never mind, unit testing is super fast. Unit testing is really focused. It's really good. It will save your life. You should totally do it. Are you guys convinced? All right, sweet. So let's start testing. So the first thing that we need to do when we're writing tests is to inject our execution environment. In Angular, what that means is we need to inject our Angular module, because Angular is a modular framework. We inject our modules by using the by using the module function inside of a before each block. Before each, if you're unfamiliar with Jasmine, does exactly what it sounds like. It runs before every test. All right, so let's go do that inside of our code. If you downloaded that example, I've pre-generated the Karma config. I've pre-generated the Karma config and pre-populated our application. Our application looks just like this. This is the weather in San Francisco right now, which that is super hot. Jeez, okay. What? I guess it's 93.76, and that is Fahrenheit. That'd be terrible if it were Celsius. All right. This is a super basic application. It's really this application is really intended on demonstrating testing, not necessarily demonstrating the power of Angular. If you want to know the power of Angular, join the webinar. I hate that word webinar. I just feel so dirty saying it. Okay, so we've already started. I've already started writing the home controller spec. So if you're following along, now is a good time to inject our environment. Again, the way we inject our environment is by using the before each function. is by using the module function inside of our before each block. And this module takes a single argument, which is going to be the name of the module that you're testing. Notice it says the name of the module that you're testing. If you're testing other modules, you can do this with other modules. You don't have to just test your main application module. By the way, I believe our module is called MyApp. Hooray, it is. All right. So inside of just a little exploration inside this application, we have a service and we have a controller. The controller handles the business logic of our application, where we say, hey, we want to make sure that we have the weather that's available to us, and the service is the thing that provides us with that data. Not terribly complex. So let's go ahead and test our controller. Let's talk about testing controllers, and then we'll test our controller. I jumped ahead. I get really excited sometimes. Okay, so if you've played with Angular, no doubt you've definitely seen this example. If you tried to convince your boss that you should use Angular, no doubt you've shown him this example. If you've been to the Angular homepage, angularjs.org, you've seen this example. This is a really super basic example of how Angular works. Where we have a bind to an input field, and we have an output bind to we have another binding to output to the binding of that input. I said binding a lot there. The controller, that specific controller, looks something like this, where we are taking whatever we put inside of that field, and we're splitting it by things on the strings. Hello, everyone, and stuff. And we're only showing the first name. So if this were right, oh, I totally misspelled my last name. There we go. Can we edit that out of the? Okay. So basically, the test that we would write for something like this. And by the way, yes, this is a good example of something you want to write. There are edge cases where you may have a dash or an underscore, and that this is a good case for writing a test, despite the fact that it looks kind of meaningless. What we want to do is we want to test that only the first name. The first name and only the first name is the only thing that gets outputted on there. So again, what we need to do is inject our execution environment. The way we do that, I've already covered that like 4 times. Okay, so testing controllers inside of Angular. Basically, if you think about what a controller is, a controller houses the business logic for the application. So it does that by using the scope. Or if you're using controller as syntax, it does that by using the object. But we're not going to get into controller as syntax right now because it's less complex. The more complex part is using the scope. Do you guys know what the scope is? Describe that. The scope itself is the glue between the view and our JavaScript code. So we would put inside of here, inside of our first name, we have a function called scope.firstName. We can call first name from our view, as we've seen here, because it's on the scope. So if you think about what a controller is simply just a house for that scope. It's just a container for that scope. So if we have access to the scope, we can test our controller. We can test what goes from our controller to the view and how we interact with the view, which is why you'd use a controller in the first place. So getting access to the scope is the crux of how we test our application's controller. To test our application, or to get access to the scope, we need to do what Angular does under the hood when it creates a new scope. By the way, testing is also a really good way of learning a framework and learning how things, especially Angular. I can't speak for other frameworks in this regard. I can, but in this regard, testing is super good for learning how Angular does stuff under the hood because you have to use the injector. In fact, we're going to talk about that now. The way that okay, so in order to get access to the scope, we're going to have to store an instance of that scope. And then we're going to have to use the Angular injector to get access to things that will be injected into our Angular application. The inject function is a helper function for doing this. Just like we do when we're writing any other Angular object, we can use the inject function to inject any injectable object into our test. In this case, we're using the inject function to inject the root scope and the controller. The controller is a service that creates controllers. So then we're going to have to, in order to write our test for our controller, we're going to have to create a new scope. We can create a new scope by using the root scope $new function. This will create a new scope. By the way, this is exactly how Angular works under the hood when our application is running. The root scope in this case is now the parent scope for that scope object. So you can use another scope to call the $new on that scope and create a child link of that if you want to do that. And then finally, we need to create our new controller and inject our new scope as the scope object of the controller. This is why dependency injection is really cool, by the way, because if you don't do this, you get the real scope thing, and you get the real scope that Angular will create inside the view, and you don't have access to it. However, you can sidestep that whole thing and inject your own injectables. Injectables is such a fun word to say. Okay. So now we can do any expectation that we want. We can set up any expectation we want on our scope. These are pretty obvious. So Jasmine has a bunch of matchers, a ton of matchers. The ones that we'll use the most often are the toBe function, which does a triple equal sign on your object. The toEqual, there it is. The toBe triple equals. The toEqual, which checks for the object equality, the exact same object, if you're unfamiliar. And there's many, many more. Okay, so we've seen that we can inject. Actually, I lied. Let's go and write our test, our first test for our home controller. So first test for our home controller, specifically, we'll test that our city starts out as San Francisco, California. So inside of our home controller, we can, that's the wrong test. There it is. All right, so inside of our home controller, as I said before, we'll keep a reference to the scope. This should be like test level. Now let's go ahead and write an injection function. Okay, so the first thing that we need to do is, for anyone who's paying attention, just shout out. Create new scope, yeah. I heard somebody say that, unless that was me making that up. And then we're going to use this scope inside of a what? Yeah, so let's go ahead and create our controller. Sweet. If you guys are following along, now's a good time to type this in. By the way, in your browsers, if you do have edu.ngrok.com loaded, you can switch between slides while I'm not switching between slides. Okay, so let's go ahead and write our tests that says the city should start as San Francisco. So let's set an expectation on our scope. This is plain JavaScript. We can set an expectation on our scope by calling scope and then however we want to access that scope. In this case, the scope would be, what would we call it? City. I can never spell San Francisco. Is that just me? Okay. Probably shouldn't have said that out loud. Okay, so if you're following along, how much time is it? When do I go till? Hopefully it's not 5 minutes ago. Okay, maybe that's why so many people are here. Oh, that's it? That's all I have? Holy cow. Okay, right. All this code will be available online, so follow along after you watch the recording. So how do we can, what? 15 minutes. Oh, phew. We're still going to skip the live part. Oh, no, we won't, since we already wrote the code. If you've written the code, the way that you run this is you type karma in your browser, or in your terminal, you type karma start. Karma start will, whoop, wrong directory. Karma start will, as promised before, it will start a live browser. As you can see, I have another browser running here. One quick thing about this browser is if you click this debug function, or that debug button, and then you open the console, you'll see that we have all these tests. The output of the tests are available in that console. Hooray, that's kind of neat. I think that's kind of neat anyway. Great. So we can use that object array to inject other objects, other injectables. For instance, in our controller, we're injecting the weather service. We can create a mock of that weather service, and we can inject that into our controller so that our tested controller is using the mocked weather service, not the real weather service, which is really good for unit testing because you don't want actual HTTP requests going out because that slows down your unit tests, which equates to slowing down your productivity. So there are cases where we want to actually have an HTTP request going out when we are making a test. We are making a test call. We want to make sure that like the appropriate request is going out. So how can we mock HTTP requests? So the way that Angular works is, especially when we're making an HTTP call, our application view looks like this, where we're saying, okay, we have my app in a really light font, and we have the HTTP service, and we're making a call to that HTTP service to go make a request, right? If you're shaking your head, ask me after. Or if you're nodding, yeah, okay. So the way that Angular looks at this is it actually calls out to another service called the HTTP backend. The HTTP backend is the thing that actually does the HTTP requests for us, not the $HTTP, even though it looks like it. What this means is we don't have to change our Angular code to support a $HTTP mock. We can simply switch out the HTTP backend mock that makes the request. So instead of using the normal HTTP backend, we can switch that out for something else. And that's the way that we're going to create a mock for our Angular application. So the way that we do that is by grabbing access to the mocked HTTP backend. This is what Karma will do this for us, by the way. We can get access to the HTTP backend mock. By the way, this is how I do injectors inside of tests. It's just a lot easier. You don't have to change functions. It's really cool. And then we need to make sure inside of our unit test specifically that all of our requests have gone out and that we have no more pending requests. This is super important. If you forget this, your test won't work. So this after each function is really important. Right. So we can set expectations on our HTTP backend by using the keyword expect. And this comes with the testing HTTP backend, which comes with the Angular-mocks library. So if you get like an error that's like, I don't know how to do this, make sure you have your Angular-mocks library included in your files array. So we can set expectations on our HTTP backend. That looks like only the first two parameters are required in here, by the way, the HTTP method and the URL to test. The other two are optional. This is the data object, which you would use if you're like testing a post request, for instance. And then headers. These are optional headers. So if you want to send in like an HTTP request or an HTML request versus a JSON request. So that will create an expectation on the HTTP backend, but how do we actually execute that function? This can be a little bit tricky too. So that looks like the expectation that we set up previously. And we might say, okay, now we're gonna call the function that calls that HTTP request. So we're gonna call API get user, which is presumably the thing that we've been testing inside of this application. That's actually not going to send out the request. If you know how Angular works, the digest loop, when the digest loop runs, that's when the HTTP request will come back, and that's when the promise will get resolved. So in order to actually execute this and test it, we have to call HTTP backend flush, which will execute the digest loop, which will run that for us. So a quick rule of thumb before we move out of unit testing into end-to-end testing is write a test for any functionality and write it after your API is settled. Huzzah. All right. If there are any questions, hold on to them. I'll be here after. I won't disappear in a cloud of smoke. That's weird. So end-to-end testing. We're going to talk about Protractor. Protractor is a tool written by the Angular team, and now there is actually a Protractor team inside of Google to manage Protractor. Team is really smart, by the way. Protractor is basically a front end for Selenium. So if you have used Selenium or know what Selenium is, you'll know its power. It can run on like pretty much every web browser known to man. Maybe not Breach, because Breach is really new, but maybe Breach. I don't know enough about it. Anyway, end-to-end testing is not a replacement for unit testing. You don't expect to write your unit tests, or don't expect to write end-to-end tests and cover your unit testing. End-to-end testing is like faking a user. It's faking a QA manager sitting at a desk clicking on things. And one of the reasons is because it's not fast. It's really slow to load a browser and connect to that Selenium WebDriver. End-to-end testing is really good for black box testing, being like, I don't care how login works. I just want to make sure that I can log in. So you write that your login end-to-end test, and hooray, it logs in. The way that we install this is by using Protractor. If you're going to follow along or use this Angular application in the future, Protractor is not included inside of this example code. So you actually have to type npm install Protractor. Oh, that's making me nervous. And then we have to install Selenium. I've already included a configuration example, and that's how I did it, just like that. Hooray! And you can look through that Protractor configuration file. In order to actually run Protractor tests, we have to have Selenium running. We do that using the WebDriver manager, and then you just pass it the start function. I'll just get to the crux of the matter. Protractor gives us access to this browser object, and this browser object is our way to connect to the browser's running instance. We can use that browser object to change the URL of our application. We can use that browser to select the object to select elements on the page, although it's easier if you don't type browser dot. Do I have that in here? I don't. Darn. And you can select elements using the global element function given to us by Protractor, and then we can use the by object to target elements inside of there. I will cover this entirely in the webinar, so feel free to join that too. Okay, lastly, the last thing that I wanted to cover today was how to, using continuous integration. Not really going to be able to cover this in its entirety. Continuous integration is super cool. It's really good for pre-deploys, which means you push to your application, you push to your Git repo, and Jenkins or whatever Travis will execute your all your tests and be like, okay, cool, it's passing. I'll deploy now. Don't actually do a cap deploy if you're using Capistrano or FTP drop, because that's just so 1998. You can run Docker on your local instance, you can run Jenkins on your local box, your development box, by using something like Docker. Docker is really awesome. This is a really awesome example of, or a really awesome box that will set up Jenkins for you. And I highly recommend you do it, even when you're testing locally. Okay. I'll leave this one up here because this is kind of a useless slide. So if you're interested in that webinar, click on that link inside of your browser if you're at edu.ngrok.com, or just go to ng-newsletter.com. Huzzah! Any questions? I have like time for 2, maybe 2. Oh, I have 5 minutes? Oh, sweet. I got through this way fast. You guys actually want to write a Protractor test? Yeah. Sure. All right, sweet. So let's see if it's still 93. Yeah, it's still 93, okay. Oh, why didn't anyone tell me that? Up here I'm like sweating bullets, like running as fast as I can. Man, my running is really relaxing, huh? Okay. Okay, so let's actually write a test to make sure that our weather actually comes back using an end-to-end test, using something like Protractor. If you are following along, we have this this protractor.conf file that is given to you with that example code. First thing that we'll have to do is we'll have to start Selenium. So The way we start Selenium is by using the WebDriver Manager start function. This is given to us by Protractor. So if you installed Protractor with npm install Protractor, you can simply start Selenium just like that. Next thing is that we will have to, whoops, why did I type thin? That was weird. In order to use the WebDriver, or sorry, in order to use Selenium, Selenium has to load up a file. We can have Selenium load up an index.html file, but I think that's kind of hacky, and it's not really good for doing anything, making any requests locally. So like if you have a template file that you're writing, if you're just loading it in your browser as like file : / / you won't be able to make that request because of the cross-origin resource safety that our browser provides us. So I like to run what's the word for this? A web server. Oh my goodness, I'm like slowing down, and so is my brain. So I like to run a web server. If you have a Mac or Python installed, you get this web server by default. So that allows us to take this file : / thing away and just head to our browser at that route. So now we can actually write our end-to-end tests. So our end-to-end test is going to do something really simple and really easy. We're simply just going to load this home page and make sure that this thing is actually getting filled out. It's a reasonable test. Let's move this guy over here and move this guy over here and hide that. All right, sweet. So in order to actually test this route, this specific route, we have to go get that route. We can get that route by using the before each function again and telling our browser to, I don't know, let's say go get that route. Oh, cow, that was easy. Okay. All right. And there was much rejoicing. All right. What's that? Are you heckling me? Okay, so in order to write a test, we'll use the it function. The it function in Jasmine creates a test. The it function takes 2 arguments. The first argument is a description of the test, and the next argument is the block of code that we'll write to execute that test. So, looking in our index.html, we see that we have a single binding inside of our HTML, and that binding corresponds to weather.temp.day. We can target, also attack, weird. We can target this content inside of our application in a bunch of different ways. You can target it using CSS if we were going to go grab the class of weather. We can target it using a binding. I think that's it, actually. We can target it using CSS, looking at the h2 tag, etc. In this case, we're going to target, when I say target, I mean select. We're going to select this element by using the binding of weather.day. We can target it using the by object, as I sped through before when I didn't realize I had more time, by using the by object and selecting it using the by binding object, just like that, or a function, just like that. So notice this by binding itself is selecting on the binding that we have in the view. That is actually really cool. Like this allows us to select something inside of Angular, like select this Angular view binding and throw that in our test. We don't have to be like, okay, I want to go get that CSS. We don't have to do like h2 tag that has a class of weather, which is one of the reasons why I promote Angular in the first place, is the fact that you don't have to know what your objects are. You don't have to know what your classes or your IDs are on your object. You don't have to know the DOM structure of your application, which is one of the powers of declarative style, is the fact that you don't have to be like, oh no, I don't know where it is because my designer put in a new div tag for styling purposes, or put in a new span tag for designing purposes. Instead, you can just select it based off the Angular idiom, which is what you want to do in the view anyway. So then we can just simply say, we can make an expectation for this, and we want to our expectation is going to be that this thing is filled out. So we can set an expectation that says our element itself our element's text simply has the text, or actually let's do this. Protractor is really cool because you can do stuff like that. Like you don't have to know the DOM structure. Anyway, to run this test, it's pretty easy. I think I mentioned it before. Maybe I didn't. To run this test, we can simply just call node modules protractor, bin protractor, and passing protractor the configuration file. This will load up. Whoop, my bad. It's not on the by. This will load up a new browser, as you can see. Oop. Oh my goodness. The demo gods. All right, so this will load up a new browser. Let's see if we can't. There it is. Sorry, that's this one. Okay, this will load up a new browser, as you can see, and that browser itself executes. Let's try this again. That loads up a new browser. Haha, there it is. That loads the actual application and will target. We'll run the application. It's your full application running in a browser in an automated way. It's really slow. Even that was really fast. If you're writing a second test, it's going to be exponentially slower, especially as it grows. So it's really good to use something like, this is why the Jenkins slides were in there, it's really good to use something like Jenkins or Travis or whatever CI server you're using. Okay, cool. I'll be here for more questions. Hooray!